In this video tutorial, I'm going to introduce you to the file carving tool Scalpel. File carving is a technique for deleted file recovery by analyzing the low-level bytes of a drive looking for specific patterns. In Scalpel's case, what we're looking for is specific signatures or patterns in the header and footer of a file, the first few bytes and the last few bytes of a file, which indicate that the file is of a specific type. Many file formats always start with a specific signature or end with a specific signature. So for our case today, what we're going to look at is we have here a USB image, which basically is from a very small 128 megabyte USB drive. I put a couple of JPEG files on there and then I deleted them. And what we're going to do is use Scalpel to search for the specific header and footer of a JPEG file. So to indicate to Scalpel what kind of files we're looking for or what kind of files we're trying to carve, we have to use a configuration file. By default, Scalpel has its own configuration file, which contains entries for signatures of many different file formats. However, and in that configuration file, each of the entries is commented out, so that when you want to look for specific file formats, you just uncomment the ones you're looking for. However, instead of using Scalpel's configuration file, we create our own here called myscalpel.conf, where I specify the specific file format that we're looking for. If we analyze that file to sort of look at how the configuration file for Scalpel looks, we can see that each entry in the Scalpel configuration file first specifies the extension, the file extension, which here is JPEG. The next letter is either a Y or an N for yes or no, specifying if the signature or the pattern we're looking for is case sensitive. We follow that by the maximum file size we're looking for. Basically, Scalpel is going to find the header, and it's going to just keep going through the drive, looking for the footer, and then it'll basically take all the data from the header to the footer and call that the carved file. So the next number indicates, this number here indicates how big the largest file we're willing for Scalpel to look for is. You can actually specify the minimum size as well. If you wanted to do that, you would first have a number followed by a colon, followed by the maximum size. So it would be min colon max, but the minimum size is optional. You then follow that by the specific header signature we're looking for, which you can see is right here. And following that, you have an optional footer signature. You don't actually need to specify a footer, or some formats don't actually have a footer signature. It should be noted that the /x over here just indicates that each of these values are hexadecimal. These signatures don't actually contain /x. So here we have two specific entries, both for JPEG files. JPEGs can have two different signatures, either this header and footer, or this header and this footer. So what we're telling Scalpel is use this configuration file to search our disk for files containing one of these two. Now, so you'll better understand this a little bit, what I have here is a image of penguins. And if we look at that with a hex editor will just show us the low-level bytes of a file. So if we open our penguin image with a hex editor, you can see that the first bytes of this file are in fact FFD8 FFE00010. And yes, if we scroll to the end, it ends with the bytes FFD9 over here. Those are the last bytes of the file, which are over here. So you can see that if we were to search for this file, penguins, we would find it because it has a matching header and footer signature. So what we're going to do, however, is search this image, which I took again from a USB drive, and try to find the deleted JPEG files on that drive. One other thing I should note here is we can specify the output directory, which is where we want Scalpel to put any images it finds, or any files it finds, really. If you do specify an output directory, which I am going to do, you can see it's on my desktop, that directory must be empty, or you can specify one that doesn't exist and Scalpel will create it for you. You cannot specify a directory that is in use that contains files. It will not work. I believe you can also not specify an output directory, and Scalpel will create its own. So now for using Scalpel, the command is pretty easy. Oh, and before, I should also mention that if you want more information about using Scalpel, you can use the man command to find out all the options and the specific format of a command, and has plenty. Or you can use Scalpel-H to get some help with the options you can use here. See, we're going to use -C to specify that we're using our own configuration file, not the default, and -O to specify the output directory. Let's clear this. So, running Scalpel, we issue the Scalpel. The first thing we put down is that we're using Scalpel. We then specify our options. Our options are going to be -C for the configuration file, and then we'll specify the configuration file which is on our desktop. You saw it before, because we're already in the desktop directory, so we don't have to move anywhere. For the output directory, we're going to specify the one also on the desktop that I showed you, Scalpel output, and after that we'll specify the actual image that we wanted to search, which in our case is the USB image for Scalpel. We should then simply be able to execute it, and you'll see Scalpel is running. It's 32% done. And again, we use a very small USB image because otherwise this would take quite a while. And now we just sort of sit here and wait while it finishes. And it's running kind of slow, but it should be done pretty soon. And you can see that it seems to have done stuff. It looked for JPEGs with a header over here and a footer over there, and it found 2 of them. And it looked for JPEGs with this header and this footer. It didn't find any, so both of our JPEGs that we found had the first, matched the first entry. And you see that it carved 2 files in 22 seconds. That's a little slow. I'm running some other stuff right now, so obviously if I wasn't running anything on my computer, it would be a little faster. And if we open the output directory, we will find that it's now produced an audit file and a directory of our images, and you can see that it has recovered 2 images. I probably should have shown you before that that directory was empty when we started. I neglected to do that, but this directory was empty, and now it contains 2 images. So clearly we were able to carve those images from our drive. As some final notes, the configuration file and the USB image are provided in the resources section of the module, so that if you want to run through this on your own or sort of follow along or maybe complete the sample challenge, you can use those to do that. And I believe that's it. Yeah, seems like that's all I wanted to say today. So, oh, and the last thing is I am using the Cert Fedora machine, as you can see in the background here. On Cert Fedora, Scalpel is installed by default, so you don't have to do any sort of installation. If you're using a different Linux distribution, you may have to install it. You can find instructions for that in the synopsis section of the module, but it's easier if you use one that's installed by default, since I'm not going to cover in the video how to install that. But that's it for tonight, so thanks for listening.